Hi, my name is Mitch Klaus. I am a STEM ambassador for WVU Extension, and I am a student at West Virginia University. I am studying exercise physiology, and I'm hoping on going to physical therapy school and becoming a physical therapist. I really love WVU because it has so many opportunities, and there's a lot of great things to do in the health science program. Today we'll be reading a book called Did a Dinosaur Drink This Water by Robert E. Wells, and we will also be going over an activity that is very related to dinosaurs and water. So, did a dinosaur drink this water? Every living thing needs water. Without it, flowers and apple trees will never grow. Fish live in water, ducks swim on top of water, and people need to drink water every single day. Water dissolves minerals and food substances, or nutrients, and carries them inside living things. When you water an apple tree, the water dissolves minerals into the soil, and then the water-mineral mix is absorbed by the roots. And it's drawn up through the tree trunk, into the trees. Then the leaves, using the water, air, and the sun's energy, produce nutrients for the apples. When you eat an apple, the nutrients are digested in your body, which is made mostly of water. Then your blood, which is also mostly water, carries the nutrients to every part of your body, giving you energy for everything you do. Water comes in three forms: liquid, solid, and gas. When it's a liquid, it pours. When it's solid, it's ice. When it's heated, it evaporates, changing into water vapor, an invisible gas. On a warm day, there's nothing more refreshing than a glass of ice-cold water. But the water we drink every day isn't new. It's been recycled, not just once, but thousands of times. The water we drink today is made up of the same tiny particles, called molecules, that have been on Earth for billions of years. Some of those molecules may have been in a water hole that a dinosaur drank from 150 million years ago. How can this be? It's because water is constantly renewed and cleaned by a big recycling system, Earth's water cycle. If you pour a glass of water into a stream, it mixes with the stream and keeps on flowing. As the stream flows down the mountain, some of the impurities that are always in stream water are filtered out, as the water passes over and through rocks, pebbles, and plants. Flowing streams are one of nature's ways of cleaning water as it moves through the water cycle. If you keep following the stream, you'll discover it flows into a river and mixes with the river water. Often, small rivers flow into longer rivers. Sooner or later, the bigger rivers flow into the ocean. Ocean water and river water are not the same. River water is fresh water, and ocean water has lots of salt. Even so, the waters mix, and the river water becomes part of the ocean. But that is not the end of the story. Water doesn't stay in the ocean. The sun heats the water on the surface of the ocean, and the water turns into its gas form, water vapor. Aided by the wind, the water vapor rises in the air. When it meets colder air, the vapor condenses, or goes back to its liquid form. It changes into billions of tiny water droplets that we see as clouds. The water in clouds is fresh, because as ocean water evaporates, it leaves the salt and the other impurities behind. Evaporation is one of nature's best water cleaners. Now the wind blows some of the clouds over land, and when the water droplets build up and grow heavier, they fall as rain or snow if the air is cold. Some of the rain and snow falls right back into the streams, rivers, and the ocean, but not all of it, at least not for a while. Some of the water seeps underground and stays near the surface. Some water may sink deeper into the ground, and it will collect in rocky areas called aquifers. Water may remain stored in underground for hundreds of years. Some snow falls on high mountains, where it's always below freezing. As the snow builds up, its great weight compresses into solid ice, forming glaciers. Some snow falls near the North and South Poles, where it is very cold, and becomes part of the polar ice. Icebergs are chunks of polar ice floating in the ocean. Water may stay frozen in glaciers and polar ice for thousands of years. Most of Earth's fresh water is frozen into polar ice in glaciers or stored under the ground. Eventually, most of the underground water seeps out into rivers, lakes, and the ocean. Polar ice and glaciers melt and become part of the ocean water. Ocean water evaporates, and the cycle repeats over and over and over again. Earth's oceans are huge. They cover about 70% of Earth's surfaces and contain about 97% of Earth's water. All water evaporates, but the oceans are so big, they play the biggest part in Earth's water cycle. The ocean is also a home or habitat for sea plants, fish, and creatures, like crabs and octopuses. All of these need salt water to live. Millions of people depend on fish and other sea life for food every day. Streams, rivers, and lakes are fresh water. They provide habitats for living things that need fresh water: plants and trees, birds, insects, and animals. The fresh water in lakes and rivers is used by people for drinking, washing, cooking, and growing food. We sail in it, swim in it, and fish in it. Lake and river water can even make the lights in your house turn on. We cannot survive on Earth without water, so we must take care of it. Yet water pollution is a problem all over the world. Toxic chemicals from landfills and factories can poison the water. Garbage and sewage in water can cause germs to spread, making people, even animals and fish, sick. Scientists say there is enough fresh water in the world for everyone, only if we practice conservation, which is protecting water and using only what we need. Water belongs to everyone, so helping take care of it is everyone's job. If we all help, conserve, and protect water, even helping in a small way, there will always be delicious water to drink, even if a dinosaur drank it first. And that's the end of the book. So anyways, this book ties very closely into the activity that I'm going to be explaining today. It's a part of the Try This at Home Grow Dinosaur Kit by STEMCARE. So I'm going to give a little bit of a demo on how this activity is played out. But if you have one of these booklets with you, you can follow step by step and you can see kind of the things that I'm going over. So in this kit, you'll have two things. You'll have a booklet inside of this bag, which is the same one that I have here. And you'll also have a little packet, which is a Grow Dinosaur. And it looks like this. So with this activity, what you'll do is you'll take out the Grow Dinosaur. And what you'll do is, first thing, before you start anything with this, you're going to want to get a piece of paper, like I have over here. You're going to put your dinosaur on the piece of paper and you're going to trace around it as close as you can. And we do this because this dinosaur, as it's called a Grow Dinosaur, is going to grow over time, and we want to see how big it ends up getting. So with your booklet on the third page, there's a ruler in centimeters. So what we're going to do before we do anything with this dinosaur is we're going to put it to the side and we're going to look at our drawing. What we're going to do with the drawing is we're going to measure the length and the width of it, so how tall it is and how wide it is. So all you can do is you can line up your 0 with the one side of the dinosaur and see how long it is. So mine is 5 centimeters. I'll write that in. It's 5 centimeters long. And it is about 2 centimeters tall. So this is a new one, but the one I have up here is the first one that I have. So I'm just writing it in this booklet to show you an example, but in this little booklet you have here, there will be a little space where you can write the length and the height of each time that you take your measurement. So you can either write it in this or in this, either one is fine. And then the next thing you'll do with it is you're gonna get yourself some water or any sort of thing. It's nice if it's a clear cup because then you can see what's going on inside of it. But what you'll do is you'll just plop it in the water and then you'll leave it overnight or for a day. And then what will happen is the next day you come in, you'll take it out of the water, pat it off a little bit so you don't get your paper wet, and then you will place it down and then measure the height and the length just like you did last time. Same exact thing as day 1, or I guess day 0. And what you should do after you do that is you should clean your water. So you should pour the water out and put new water in because the dinosaurs will grow best with clean water. So what you can do is you can keep doing this each day. And I have a little explanation of the second day, and it grew by 2 centimeters and by 1 centimeter here. And you can do this for 3 days or 4 days or however long you want, but it'll grow really big. But the cool thing is if you take your dinosaur out of the water and you put it on open air, it will actually shrink. And I'm gonna kind of explain how that happens. There's a little bit of science behind it. So you can kind of read about it in your kit if you have that. But the Grow Dinosaur is made up of polymers. And a polymer is actually very simple. It's a very long chain of repeating molecules. So water is a molecule, but a polymer is basically, if this is a molecule, it's going to be a long chain of molecules. So these Grow Dinosaurs that we have right here are made up of 2 different types of polymers. One is called hydrophilic, and the philic ending of hydrophilic means that it loves water. So what will happen is when you put that dinosaur in the water, it will absorb the water, and that's what causes it to become bigger, because it's when it's gaining that water, it'll increase in size. But if it was only hydrophilic, the Grow Dinosaur would eventually break apart because it would absorb so much water that it would tear it apart. But the second type of polymer in it is a hydrophobic, and that means water-fearing. And that polymer is a long chain of molecules that hates water, and it will not absorb any water, and therefore that will keep the structure of the Grow Dinosaur and let it get big without breaking. So that's just a little explanation on it. If you want to take this farther, what you can do is each day you take your measurements, you can multiply the length times the height, and you can calculate your area. And the area is the total mass or total space that your Grow Dinosaur takes up, because length is just how long it is, height's just how tall, but the space, the area, if I draw a box, will be this entire space. So what you can do is if you get your area each day, you can make a graph like this. And so just make a graph that's like a half square. And then you can put on the x-axis, which is left and right, you can put your days. So here I have day 0, day 1, day 2, day 3, day 4. And then on the y-axis, which is up and down, you can put the area. And what you'll do is you'll go to day 0. And so let's say my area was 10 that day. So I put a little dot there. The next day, day 1, the area was a little bit bigger because it grew. So the dot is a little higher up, closer to 20. And as you keep going, you can kind of draw a line and you can compare the way it changes and grows over time. So that's kind of cool if you want to take it a little bit farther and just kind of see how the area changes, I guess. But that about wraps it up. That's the Grow Dinosaur kit from STEMCARE. If you are interested in this activity or other activities that may be similar to this, you can visit the STEMCARE website to look for more information and stuff that's related to that. But thank you for joining.